Is it possible to start math without discussing the basic ideas about sets? Unfortunately, guys, it's not. Sets are so fundamental that it would be a big mistake to start without them, even in high school math. Why? Look at the numbers we're using every day. What are they? They're elements of a certain set. They're what? Yes, they're elements of a certain set. A set is a well-defined collection of distinct objects, also called the set's elements. Well, what? Well-defined. That means that there is a rule that enables us to determine whether a given object is an element of the set. In other words, it has to be clear if an element is either in a set or not. To put it in a different way, imagine a set as a container where we store things, in this case numbers. But what does this have to do with the numbers we use every day, like I said at the beginning? Well, we can imagine that all the numbers we use for counting are in our container, or if we use the proper math terms, in our set. Our elements are written within the curled braces, which are used to enclose the elements. Inside the curly braces, we write our elements and we separate them with a comma. When there are too many counting numbers for us to write down, we put 3 dots at the end, called an ellipsis, which indicates that there is no final element and that the listing goes on forever, or infinitely. The last thing for us to do is give the set a name. That's very easy. Usually we put an uppercase N with an extra line at the beginning of the letter, called a double struck N, which is the common symbol for natural numbers, and the equal sign, which means is equal to, in front of the curled braces. Usually some important sets like the natural numbers are designated by single capital double struck letters. Don't forget the equal sign after the N, which means that the N represents our container with the elements included. In other words, the N and the container are equal, or let's say represent the same. Another thing I want to say is that because the elements of the set are distinct, we never repeat elements. By the way, this method of putting the numbers between the curled brackets and separating them with a comma is called the roster method. A set can also be written in set builder notation, where the elements of the set are described but not listed, like here in this example. M is equal to the set of all x such that x is a counting number less than 4. The same set written using the roster method would look like this. Okay, let's go back to other numbers which we use in addition to natural numbers. Some mathematicians include the 0 in the set of natural numbers, while others put the 0 in the N symbol to clarify that the 0 is included in the set. I say it again, some put the 0 in the set of the natural numbers without labeling the N with a 0, while others label the N with a 0 to clarify that the 0 is included in the set. Other mathematicians call the natural numbers including the 0 the whole numbers, and give them a new symbol, the W, which looks like this. It's also common to designate the whole numbers with a single capital double struck W, like we did with the natural numbers and the double struck N. Okay, finally we include the 0. What other numbers do we also need? Well, think about the temperature when it's very cold, or think about your bank account. Both can go below 0, right? Below 0 means negative, so we need negative numbers too. We call these negative numbers, the 0 and positive numbers, integers, and represent them with a double struck Z symbol. Negative numbers are numbers that have a negative sign in front of them, indicating that these numbers are below 0, or if we represent them on a number line, that they are to the left of 0. For comparison, positive numbers are to the right of 0 on a number line. A number line is a graph to represent the sets of numbers. You know what? Let me draw a number line just to help you visualize it. Maybe we can put all the numbers of all of our sets on it. Let's start with the natural numbers 1, 2, 3, etc. The arrow means that it follows the same pattern in a positive direction. Putting whole numbers on our number line is easy because we've already put the natural numbers. We just have to add the 0 for the whole numbers because the whole numbers also include the 0. To put the integers on our number line, we just have to add the negative numbers because the 0 and the natural numbers are already here. We'll start with the -1, -2, -3, and the arrow means that it follows the same pattern in a negative direction too. That looks really good now, but are these the only things we can put on a number line? What if we want to express a fraction, like 1/2 or 5/2? These numbers are elements of the so-called rational numbers. By the way, every fraction, or let's say a rational number, has a top number, which we call the numerator, and a bottom number, which we call the denominator. The line between them we call the division bar. But be careful, the denominator can never be a 0, because that's not defined, which means mathematicians didn't define what dividing by 0 is. It's an impossible mathematical operation as far as we know. Okay, let's go back to our number line and mark some rational numbers. Why did I say some rational numbers? Because we can't mark everything in this section from -3 to 3 in the same way we did for all integers. That's a good question for you guys. Why can't we mark all the rational numbers here on our number line? Write the answer in the comments. Okay, let's mark some of the rational numbers. 1/2, 5/2. There are other rational numbers like 1/3, which is 0.3 repeating as a decimal number. The line over the 3 indicates that the 3 is repeating and not ending. There are other kinds of numbers where after the decimal the numbers continue infinitely, but actually don't repeat. And indeed these kinds of numbers that we can't express as a ratio of integers, also known as a fraction, are not rational. We call them irrational numbers. I am sure you have heard of these kind of numbers. Some examples would be square root of 2, pi, e, etc. Let's mark some of them on our number line. The crazy thing is that there is even a set of numbers where none of them can be represented on our number line. These are called complex numbers, but I will make an extra video about these guys later. Now we have a good basic knowledge about the most important types of sets. Let's make a diagram of all our sets to make it visually more clear. We started with the natural numbers. If you will remember, we used to count. Then we added the 0 to the natural numbers and called this set whole numbers. After that, we added the negative numbers, which we called the set of integers. Then we added the set of rational numbers, also called fractions, and the irrational numbers, where the decimal number is non-terminating and there is no repeating pattern. Altogether, we call these numbers real numbers and denote them with the symbol R, again with a double-struck letter. And this is why when we put them on a number line, it's called the real number line. Besides real numbers, we have the complex numbers, but they are not on our number line. Like I said, I will make an extra video about the complex numbers. Let's make a quick recap. First, a set is like a container where we can imagine things are included, and these things are called elements. Every set has a name and we write its elements in curly brackets, separated by commas. Sets can also be written in the set builder notation, where the elements are described. Second, the most important sets in math are the set of natural numbers, the set of whole numbers, the set of integers, the set of rational numbers, and the set of irrational numbers. All these sets together are called the set of real numbers. We also have the set of complex numbers, which I will explain in another video. I wanted to add one last thing. The set of natural numbers, whole numbers, integers, rational numbers, and irrational numbers are all considered subsets of real numbers, which is because all numbers of the different sets are included in the set of the real numbers. But be careful guys, The real numbers are not a subset of the integers. As an example, because not every number of the real numbers is included in the set of the integers. Okay guys, that's what I did for you. If you want to do something for me, hit the bell button, share and subscribe. Happy learning guys.